All right, we're looking at Chapter 4, Lesson 3, Rate of Change in Slope. So the objective for, sorry about that, I bumped that. The objective for today is to find rates of change in slopes and also relate a constant rate of change to the slope of a line. So a lot of terminology here, and we will go ahead and decode these words and figure out what they mean. Let's get started. So the first one we saw was a rate of change, or one of them we saw was a rate of change. A rate of a change is a ratio, and remember the ratio, one of the ways, and I like to think about the word ratios, I just like to think about a fraction, okay? So whenever I see the word ratio, I know that I'm going to be dealing with a fraction. I know after the word ratio, they're going to tell me, right, what goes on top of the fraction, right? Because every fraction has a top and a bottom, right? So after the word ratio, it's going to tell me what is on top of the fraction, and then it's going to say like something like 2. And then once I see that word 2, that means that they're going to give me the information that goes on the bottom of the fraction. So a rate of change is the ratio that compares the amount of change in a dependent variable to, okay, there's that keyword to. So this is giving us a formula. So we have rate of change, right? And so all of this, after the word ratio, this is all referring to what goes on the top of the fraction. Is the ratio that compares the amount of change. So it's change in a dependent variable. That's really what it is. So that's what goes on top. Change in a dependent variable. And what is a dependent variable? They in mathematics, they use these like lovely words. And change is a triangle. And the dependent variable is y. So change in y, or really the difference of the y values. That's what change is talking about. So it's talking about you're going to have two y values and you're going to find the change of them. So you're going to find the difference, which means you're going to have two y values and you're going to be subtracting them. That's basically, you're going to be subtracting the y values. That's what change in the dependent variable means. All right, so then it says, okay, so rate of change is the ratio, that's a fraction, that compares the amount of the change in the dependent to, okay, that word to is a key word because now it's saying, okay, we're switching and I'm going to tell you what goes on the bottom part of that fraction. And what goes on the bottom part of the fraction is the amount of change in an independent variable. So change in an independent variable. And so what does that mean? Well, change, I'm going to use that little triangle. That means change in math. The independent variable is x. So what you're doing is you're taking the difference in x, and now you're going to be subtracting the x values. So it's a ratio where you subtract the y values, and that's on top, over you subtract the x values, and that's on bottom. That's what a rate of change is. It's trying to figure out the rate at which things change. So let's look at our first example here. So in example 1, it says the table shows the average temperatures for 5 months in a certain city. Find the rate of change for each time period, and during which time period did the temperature increase at the fastest rate. Okay, so what we have to determine is first, right, rate of change is what? Change in dependent variable over change in independent variable. So change in y over change in x. Okay, we got to figure out what is the dependent variable and what is the independent variable. So it says the table shows the average month in degrees for 5 months in a certain city. Find the rate of change for each time period. Okay, so what I'm going to say is that the dependent variable, what depends on the other thing? So here in this example, the temperature depends on the month. So we would have the temperature being the dependent variable, and the month would be the independent variable. Okay, so the dependent, this is our y, and the independent, those are our x's. So what we're going to be finding, remember, is that change in y over the change in x. So we're going to look at the time period from 2 to 3 first. So from month 2 to 3, what happened? So I'm just going to say, okay, so from 2 to 3, what happened? So I'm going to look at the change in the y values, right? Because the rate of change, which is what they're asking us to do, is the change in y over the change in x. So I'm going to take the difference of these two values, so 56 minus 56, all over 3 minus 2. And what is that? 56 minus 56 is 0 over 3 minus 2, which is 1. So 0 over 1 is just 0. Okay, so from 2 to 3, the rate of change was 0. All right. Let's go ahead and look at the next one. Let's look from 3 to 5. So from 3 to 5, I'm going to take, find the difference, right? Set change in y over the change in x. So the change in y would be 63 minus 56 over 5, take away 3. And 63 minus 56 is 7 over 2, which is, equal to, I'm just going to change it to a decimal, or we can just keep it as a mixed number. 2 goes into 7 3 times, so 3.5 or 3.5. Okay, so that's what the rate of change would be for this one. Okay, which is bigger than here. Okay, so we know that 3 to 5 has a greater rate of change, a greater rate of change than from 2 to 3. So let's look at the next one. We're going to look at from 5 to 7. So 5 to 7. And it's going to be that change in y over the change in x again. So the y, we're going to go 71 minus 63 over 7 minus 5. 71 minus 63, what is that? That would be 8, right? Yeah, 8 over 2, which is equal to 4. So that one's even bigger than all of the other two, so that's good. And then we have to look at the next rate of change from 7 to 8. Okay, so for this one, it's the change in y over the change in x. That's what the rate of change is. So we're going from 72 minus 71 all over 8 minus 7. So 72 minus 71 is 1. 8 minus 7 is 1. 1 over 1 is just 1. So there we have it. There are all of our values. 0, 3.5, 4, and 1. And so it's asking us to, during which time period did the temperature increase at the fastest rate? And that would be the biggest number, which would be right here for 4 from 5 to 7. So we would say, okay, first it wants us to find the rate of change for each period. Okay, we did that. And then during which time period did the temperature increase at the fastest rate? We would say the temperature increased at the greatest, oops, that's not how you spell greatest. Oh, just get rid of it. Greatest rate from month 5 to 7. All right, and there is our answer. Perfect. Okay, let's go ahead and look at the next one. So this one says the table shows the balance of a bank account on different days of the month. Find the rate of change during each time interval. During which time interval did the balance decrease at the greatest rate? So first we have to go ahead and determine, okay, what is the independent variable? What is the dependent variable, right? So what depends on the other? And I'm going to say that the balance depends on the day. So this is going to be our dependent variable. which is y, and which means our independent variable is x. And it's really important that you distinguish between what's y and what's x, because that depends on what goes on top of the fraction and what goes on the bottom, right? Because the rate of change is the change in y over change in x. So you have to make sure that you're putting the right numbers on top of the fraction and the right numbers on the bottom. So let's look at the first one. So from day 1 to day 6. So 1, 2, 6, what happened? So we're looking at the rate of change. So we're going to take these two values here, and we're going to go 285 minus 550 all over 6 minus 1. Okay. And so we just need to determine what is the difference there. We know our answer is going to be negative, right? Because the bigger number is negative. Okay, so I'm going to just take this on this side. 550 minus 285. I'm going to have to borrow, right? Making that a 4, that a 10. 10 take away 5 is 5. Borrow again. 4 take away 8 is 6. 4 take away 2 is 2. That's negative 265. All over 6 take away 1 is 5. Okay, now 5 does go into 265 evenly, so we need to reduce this fraction. So I'm going to move it up a little bit. I'm just going to have to do that division real quick. So 265 divided by 5. 5 goes into 26. Oh, it doesn't go into 2, but it does go into 26 5 times. 5 times 5 is 25. Subtract 1, drop it like it's hot. 5 goes into 15 3 times. 3 times 15 is, 3 times 5 is 15. 15 take away 15, 0. Boom, no remainder. So we know that our rate of change is actually equal to negative 53. Okay, and that makes sense because it's decreasing by 53 dollars, and it's like 53 over 1. So it's like decreasing by $53 for each day, because the y is the amount of money. So if we wanted to write this, we could write it's decreasing by $53, right? Y is the balance per day and per 1 day. Okay, so that's what the rate of change is for that first time period. Okay, let's go ahead and figure out what it is for the next time period. So what are we looking at? From 6 to 16. Okay, so we're finding that change in y over the change in x. So it's going to be 210 minus 285 all over 16 take away 6. And what does that end up being? The difference between 285 and 210, I'm not sure. 285 minus 210, 5, 7. So 75. All right, cool. So it's going to be negative 75. 16 minus 6 is, it's 10, right? Okay. Then we just want to go ahead and, since we're talking about money, we're actually going to make, I always say, oh, leave it in fractions, but we're talking about money, and money is actually written in decimals. So this is actually, if you divide this by 10, it's going to be negative 7.5, which is the same thing as losing $7.50 per day. So during this period, they lost from 6 to 16, they lost, the rate of change was losing $7.50 per day. So that was the rate of change during that time period. Let's go ahead and look at the next time period, from 16 to 22. So again, we're trying to find that rate of change. So we're going to go, ooh, this one's nice. I like this one. 210 minus 210. All over $22 minus 16. That's 0 over, what's that? 6. 0 over 6 is 0, which means they lost $0 per day. Okay, they didn't lose any money during that time period. That's what that means. That's nice. And then lastly, we need to find from, I'll move it over here, 22 to 30. The change in y over the change in x would be 175 minus 210 all over 30 minus 22. What's that going to be? 25, 35. So negative 35 over 8. Okay, nothing goes in evenly there. So since we're talking about money, I'm just going to divide it. 35, oh, that's not even a 5. That's a 7. 35 divided by 8. 8 goes in there 4 times. 4 times 8 is 32. Then we subtract. Make that a 0. Drop it down. 8 goes into 30. How many times? 3 times. 3 times 8 is 24. Borrow, that's a 6. Drop it down again. We get 8 goes into 60 7 times. 7 times 8 is 56, which then is 40, which is then a 5, right? And so this 5 is going to round that 7 up to an 8. So that means that they lost, oh shoot, I need to put a negative. This equals a negative $4.38 per day. Okay, and see how I went to the tenths, hundredths, thousandths, and I had to go to the thousandths because I'm talking about money. Money is written in the tenths and hundredths, but I need to go to the thousandths to know whether that 7 stays the same or it rounds up. So here is our rate of change for this particular time period from 22 to 30. So we need to figure out, well, what is the greatest? What is it asking? During which time period did the balance decrease at the greatest rate? So I think that it is pretty clear that losing $53 per day would be the greatest rate for decrease. So we would say the balance declined at the greatest rate from day 1 to 6. All right, and that's how you show your work and write your answer. Okay, that's it for example 1. I will see you in a little bit for example 2.